This is a quick overview of the MechLab lab interface. We're going to be going through what the lab interface is, how it gets used, where items get configured. This is going to be a brief overview. Now for this example, I'm running a project that is simulating values from a National Instruments DAC with an encoder channel here and a external industrial PLC that we're talking to through the Mech server. We'll have some values to play around with, but you won't see much changing on the screen because it's not a live system, it's simulated. Let's go ahead and start the lab interface. The MechLab interface is the primary interface used in MechLab testing applications. The point of the MechLab lab interface is that a test engineer, user, operator can put together an interface for a test that doesn't require any coding. So the MechLab lab interface is completely configured through the system editor in the display section. Now there's a lot of information on configuring the display section in the system editor tutorials. So for complete information, you're going to want to go through and review that tutorial series. So let's start by giving a brief overview of the available tab displays in the lab interface. It starts up in the test display. Here we're going to have metadata that we can enter in the information section. And in the results section, we've got a cycle data table and a results table. We have buttons to reset data, export data. The method tab is split into two displays. We have the system tab. System is used for configuring operation of equipment. In this particular example, there is an ADC cannon that has pressure that can be configured, a catch gate that has a configurable delay, home offsets for the motors. These are values that are not necessarily configured every time you run a test, but are kind of more like a machine configuration. For values related to your specific test, or for values that are factors in a calculation in your script, those usually go into the configuration tab. And you can see here this particular test has a bunch of calculation values that are related to the items being tested. The control tab is mostly pre-configured automatically based on the settings in the project, and it generally remains the same. In the display area, you get a display of the status of a motion axis. There's up to 6 motion axes supported. In this particular application, there are only 2, the X and the Z axis, so only those are displayed. As others are utilized, they get automatically added to the display tab. The same is with the L panel. The L panel automatically adapts to how many axes you have and whether or not you have rotational axes. The R panel is actually configured in the project file and is project specific. So as you're developing the test and want to control certain devices on the machine, that can be configured in your project. The dashboard is basically feedback to the user after a test. The user panel is entirely configurable, and the script panel gives us output from the Python script if Python integration has been enabled. Let's go through some other aspects of the screen here. The header is across the top. This section of the header, which is the majority of it, there's our value displays. Which values are displayed up here are configured in the project editor. So depending on your test configuration, you can have one or none or several items there. The panic button is always there, always available, and is basically a quick stop or a reset button. The footer is just like the header. This section here is completely configured by the project file. So all these indicators here are specified in the project. This button is specified in the project, and its function is specified in the project, as well as this one. The start button is always there, so that once you can start a test. There is also optionally, you can configure to enable a stop button as well. Some processes benefit from having a stop button. Some tests, you just press start and run until they finish, and you don't want to stop them in the middle unless there's an emergency, in which case you would use the panic button. So you have those configuration options. Most of what you see here is completely configurable. If we come and we look here at the information section of the display, we see that all of these fields are defined, which gets them displayed here. And their values get routed in the project to the proper tag by specifying the value that they belong to. The cycle data table is populated through the method group. By adding fields here, they go into the table, and those fields also become available to you in the processing script. Results, the same as cycle data. These result fields are configured here, and when the lab interface starts up, it detects that in the project and creates the fields. Fields in the cycle data table can be read-only or editable, depending on how you configure the project. So perhaps you have a comments field here that might come in, and an operator can type in comments, but other fields you might want to be read-only. Now that's easily configured using the editable property of a tag. System is configured in the system group of display, as well as configuration is configured in the configuration group of the display. Header, footer. This section of the control page is configured through the control group under display. Different tests might have different operational needs, so we can lay out the desired buttons and fields and such using the grid layout that's available in that section. The dashboard is very useful for behind the scenes information on what happened in a processing script, feedback from devices and such. This is entirely configurable under the dashboard area. Again, it's a grid layout, so by adapting row index and column index, you can place all sorts of different widgets there on the screen. The script panel is always available. If an error occurs in the script and calculation, either from a typo or from a bad value coming in that causes the Python script to error out, then that information, including line numbers where the error occurred in the description, are displayed in the error field here. But you can also put print statements into the Python script. Those are captured and relayed back here. So all sorts of information is available to the operator. The MechLab lab interface supports both keyboard and mouse and touchscreen usage. So we can come here and we can type into bat code using a standard keyboard. If we don't have a keyboard and mouse on the machine, if it's touchscreen only, we have a keyboard button. For text fields, alphanumeric fields, the operating system's touch interface keyboard is brought up. For numeric fields like temperature, we have the option to type, or we can use the built-in touch keypad. So we have flexibility with how we interact with the interface. that is going to do it for this video. Please check out some other videos on the channel on MechLab6 or other equipment made by ADC. Also, feel free to reach out to us at automateddesign.com with questions or requests. Thank you very much.